We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Okay, good morning, friends. Myself, Professor Janak Patel from SN Patel Institute of Technology, RC, Badoli. Now, today we are start with the one chapter of the subject control of electrical drives. So, 260913. Okay, so we are talking about the DC drives. So, let us start first. DC drives. Okay, so we know that the conventional method for the speed control of the motor is nothing but the speed and is nothing but it is EB by phi. EB is nothing but it is back EMF, phi is the flux. Okay, now EB, we know that EB is equal to V minus IA RA, right? Okay, so we can say that there are on that equation, on this equation base, there are 3 methods, right? EB is equal to V minus IA RA, right? So EB can be controlled with the two method. Either we are controlling the VA, that method is called as a voltage control method, and either you can control this EB by RA, varying the RA. So this method is called as a by varying the resistance in the armature circuit, that is called as a rheostatic control. Okay, and third method is called as a by varying the flux control, that is at denominator flux, and flux is controlled by the varying the field. Okay, so as we control the flux, you can also control the speed, because speed is nothing but it is EB by phi, right? Back EMF by phi, and back EMF is controlled with the help of voltage and with the help of armature resistance, that is called as a rheostatic control, right? Okay, instead of that, the another one special category is there, because the DC motor speed can be controlled through the power semiconductor switches, and that switches are nothing but it is the IGBT, MOSFET, SCR, thyristor, GTO, all are there. And this control is also called as a Ward-Leonard control, and that is called as a solid state speed control of DC drives. Okay, now moving towards the next side, that the type of DC drives. Okay, so basically there are 2 types of the DC drives are there. First, we are obtaining the DC from the rectifier, AC to DC, that is rectifier, and that DC, that is we are using the phase control rectifier. So that control rectifier can given us the controlled DC voltage, and that is given to the DC motor as per the requirement of load. So first type of the DC drives is the phase control rectifier fed DC drives, and second method or second types of drive, that is called as a chopper fed DC drives. Let's suppose our source is DC only, then variable DC can be obtaining by including the one converter between the fixed DC, so we can obtaining the variable DC, right? Now again, this phase control rectifier fed DC drives, there are again 2 type. So according to the input supply, there are 2 types, and according to the quadrant operation, there are 3 types, right? Okay, so the according to the input supply, the single phase rectifier fed DC drives and 3 phase rectifier fed DC drives, as I told you that our source is AC and we require the variable DC, then obviously we are use the rectifier. But according to the phase availability, there are 2 types of the rectifiers are there. single phase rectifier and three phase rectifier. Okay, now the single phase rectifier, if we are used in the DC drives, then it is called as a single phase rectifier for DC drives. And again, there is a three phase rectifier is also used, so that is called as a three phase rectifier for DC drives, right? Now B type is the according to the quadrant operation. We know that there are four quadrants of the drives are there. In the first quadrant there is a motoring action, second quadrant there is a forward braking operation, third quadrant is the reverse motoring operation, and fourth quadrant is called as a reverse braking operation. So according to that quadrant operation, there are again rectifier drives are there, DC drives. First is the one quadrant operation drives, second is the two quadrant operation drives, and third is the four quadrant operation drives. So this is all about the phase control rectifier fed DC drives. Now second is the chopper fed DC drives, right? So in that case, again there are three types. Okay, so first is according to the quadrant operation. So there is a one quadrant chopper drives, second is the two quadrant chopper drives, and third is the four quadrant chopper drives. Okay, so this is all about the types of DC drives, right? Okay, now second, we are mostly concentrate on the chopper drive. In this lecture we are concentrated on the chopper drives. So in the chopper diagram, in the chopper drive, here you see the block diagram of the chopper drive. Okay, so if you see in the block diagram that the availability of the supply is the fixed DC. So fixed DC is fed to the DC chopper, and DC chopper convert this fixed DC into the variable DC, right? And this variable DC voltage is fed to the DC motor. Okay, and by varying the DC voltage, the motor speed can be controlled according to the requirement of load, right? Okay, so this is the basic block diagram of the chopper drives, right? Okay, now simply move towards the advantage of this chopper drive. What is the advantage of this chopper drive? So very first advantage is it is very high efficient, right? Okay, the efficiency of this drive is very high. The reason behind that is there is only one converter is there. The voltage will be converted in only one stage, that is a DC chopper, and that's why the efficiency of this drive is very high, right? Second advantage is the flexibility in the control, right? Second advantage is the flexibility in the control. The controlling flexibility is very high because there is only one converter, so you can just control only one converter, so you can obtain very high flexibility, right? Third advantage is light in weight. As I told you, there is only one converter is there, so weight of this drive is very less. Space is also very less, so these are also advantage of the DC chopper drives. Okay, again it is relevant with that the size is small. Next is the response of these drives is also very fast, quick response, right? Why the quick response is there? Because only one converter is there, so obviously as you give the signal, get signal to the chopper will convert the fixed DC into the variable DC, so response is very fast. So that is also very important advantage as we are talking about the drives operation. Okay, and last is the regeneration down to very low speed. So these are the advantage of DC chopper drive, right? Now let us see what are the types of these DC chopper drives. Okay, so that we are seen in the next drives. So that is the okay, before that we are talking about the applications of the DC drives. So what are the applications of the DC drives are there? So very first is the battery operated vehicle. We are use the electric vehicle. Today there is a, we know that the fuel cost is increasing day by day, the availability of the fuel is also very less, so obviously the world will be moved towards the electric vehicle, right? And that's why we obviously move towards the electrical vehicle, and electrical vehicle use the motor. So obviously we are use the to control for this motor, and that control is nothing but it is called as a drive. So battery operated drives are there, so where we are use the DC chopper drives. Second is traction motor in the electric traction. So traction motor, uh, in the past there are we are use the uh, series motor, DC series motor, because of the high starting torque. But nowadays the traction are also works on the principle of DC chopper. By use of this chopper we can use the separately excited motor also for the operations of the traction. Third is the trolley car. Fourth one is the hoist. Fifth one is the electrical braking. So these are the some examples of the DC chopper drives. There are so many examples are there, but just we are discussing about the very most popular um, applications of the DC chopper drive. So there are so many others applications are also there where we are using the DC chopper drives. Okay, now let us we are talking about the types of DC chopper drive. As I already told you, there are three types of the DC chopper drives are there. First is the first quadrant, second quadrant, and four quadrant drives. So again, first quadrant chopper, that is called as a type A chopper. Second quadrant, that is called as a type B chopper. Third is the two quadrant type A chopper, that is nothing but it is chopper C. Okay, so you already study about this all this chopper type A, type B, type C. Fourth is the two quadrant type B chopper, or it is also called as a type D chopper, right? And fifth one is the four quadrant chopper, or it is also called as a type E chopper, right? I think in the power electronics 1 subject, which is offered by our GTU, uh, most of you knowing about the chopper, the type A chopper, type B chopper, type C chopper, and type D chopper, and lastly type E chopper, that is called as a four quadrant chopper, right? Okay, so let us see one by one. Okay, so first is the first quadrant, or it is also called as a type A chopper, or it is also called as a motoring chopper, right? Now in the past the series motor was used in the traction, right? Because its high starting torque, as I already told you, it has number of limitation. But before that we do not have any option, so that's why we are depending on the DC series motor. But nowadays there are so many options, so we are talking about the limitations of the DC series motor. The field of the series motor cannot be controlled easily by the static means. We cannot control the speed of the DC motor by means of the field control easily very, right? And if the field control is not employed, the series motor must be designed. If we do not have the field control method, then we must be design the series motor in such a way that its base speed equal to the higher desired speed of the drive, right? And what is the problem? The higher base speeds are obtained using the fewer turns of in the field winding, because we know that speed is nothing but it is AB by F phi. So if the phi is very less, so number of turns we are using the flux field is less. So field is less, and as the field is less, the higher base speed we can obtain, right? But this will reduce the torque per ampere at zero speed and low speed. So presently, so that's why there is so many limitations of the DC series motor. Presently the separately excited motors are used in a traction drive, right? Because of the limitations of the series motor, separately excited motors are now prefer even for the traction application, right? So that's why it is called as a motoring control. A transistor chopper controls separately excited motor drive. We can see in the next slide. So that is all about, as I told you, that presently the separately excited motors are also used in a traction. So next slide is the transistor chopper control separately excited motor drives, which is shown in the next figure. That here If you see, so this is the supply voltage, this is the supply voltage, okay, and it is very simple chopper. This is the fixed DC voltage, okay, that is given to the switch. Then there is a one freewheeling diodes are there, and this supply is given to the motor. Motor is consist of the internal resistance, internal inductance, and back EMF armature, right, which produce the back EMF. So this is called as a motor in chopper, right? Okay. Now, if you see the waveform of these drives, okay, so here there is a waveform of this type A chopper drive, right? So if you see that which type of the control we are using these drives, that the current limit control is used in this chopper. In the current limit control, the load current is allowed to vary between the two limit, this IA1 and IA2, right? The load current which is flowing from the motor, that is control between the two limit, that is IA2 and IA1, right? Okay, upper limit and lower limit. The on and off time, this is on time and this is off time, right? So this time is also controlled, adjust automatically, right? When the current increases the upper limit, at that time the chopper is become turned off, right? And load current is flowing from freewheeling diode. So initially the operations of drive is that chopper is on, the fixed DC voltage is flowing, current is flowing in this way from fixed DC voltage, switch, and from motor, right? So the current is start to increases like that, okay. Once it reaches the maximum limit, at that time the chopper is become turned off at this instant, right? Okay, so what happening, the current remaining current is start to flow from this way, from the freewheeling diode, okay, and this current is start to decreases, right? Once it decreases at the lower limit, at here IA1, the switch is again turned on, chopper is again turned on, the current again start to increase, right, in the load current IA and the voltage VA are shown in figure. By assuming the proper limit of the current, the amplitude of the ripple can be controlled. We can, assuming the proper limit of current, you can easily control the ripple. The lower the ripple current, it means how to control the current, proper limit of the current, by controlling the ripple, and the current is lower means ripple is lower. But the higher the chopper frequency, it will increase the chopper frequency, and we know that if the chopper frequency is increases, then the switching losses are also increases, okay. So discontinuous conduction avoid in this case. The current limits control is superior one. How? So during the on period, this period, during on period means 0 to T on to T, 0 to T to T on, right? So during that period, the duty interval, the motor terminal voltage VA, that is equivalent to supply voltage VS, right? And the armature current increases from IA1 to IA2, right? Okay. Now the operation is described, this operation during the interval of 0 to T on, if we write down the equations for this equivalent circuit, write down for equivalent circuit, sorry, if we write down the equivalent equations for the equivalent circuit, then it is nothing but it is IARA plus LA into DIA by dt plus EB is equal to Vs. Chopper is turned on at T is equal to T on. Chopper is turned off at T is equal to T on, and during the off period the chopper free wheels interval will be started, that is from T on to T, capital T. So the motor current free wheel through the diode, freewheeling diode FT, and the motor terminal voltage is VA, that is become 0. Voltage is not appear across the motor terminal, but still the current is flowing from. During that period, the equation is nothing but it is IRA plus LA into DIA by dt into EB plus is equal to 0. Okay, so this is the equation when the chopper is on, and this is the equation when the chopper is off. So during that period, we are obtaining the voltage across the drive is VA, and during this period, the voltage we are obtaining across the drive VA is equal to 0. So from these two equations, we can write down the output voltage, output waveform figure from the VA is 1 by T integrations from 0 to T on Vs into dt, right? So Vs we are came outside, so Vs by T integration from 0 to T on into dt. So Vs by T, if we solve this, then Vs by T in the limit T from 0 to T on, so Vs into T on by T, right? And T on by T is nothing but it is called as a delta, or it is also called as a duty angle, duty cycle. So VA, voltage across the armature VA, is nothing but it is delta into Vs, or it is also called as a alpha into Vs. So delta or alpha, it is nothing but it is the duty cycle. So in the next cycle where the delta or alpha is nothing but it is the duty cycle, and it is given by on period divided by total time T, right? So T on by T. So VA is equal to EB plus IRA, but VA is nothing but it is delta into Vs. So delta into Vs is equal to EB plus IRA. So IA is equal to delta into Vs minus EB by RA. Now again we are know that EB is equal to Km into omega m, because EB is directly proportional to EM. If we are removing the proportionality, then Km is there, that is the constant. Torque T is equal to Km into Ia, because torque is directly proportional to the armature current. So Ia is equal to T by Km. Now we have the two equations for EB, right? That EB is equal to VA minus IRA, and EB is equal to Km into omega m. Compare these two. So we can obtain Km into omega m is equal to Va minus T by Am into Ra, or Ia into Ra. Instead of Ia we are put this T by Km. So omega m is equal to Va upon Km minus T by Km square into Ra. So final equations for this speed is omega m is equal to delta into Vs divided by Km minus Ra divided by Km square into T. So if we properly observe this equation, then from this equation the Km is constant, torque T is constant, Ra is also make constant, but the Va is become variable. But how we are obtaining this variable Va? By simply control the Va is equal to delta into Vs. So if we control this delta, or it is also called as alpha duty cycle, we can easily control the Va. So if we control the delta, then you can controlling the speed of the motor in the first quadrant. Okay, so this is all about the type A chopper. Okay, so thank you very much. And if you have any query, then ask me the question on my following email ID. My email ID is the janak.patel@snpitrcac.in. Okay, so thank you very much. Once again, we are started with the next lecture after some time, which is on the type B chopper. Thank you very much.